In a global landscape where the pursuit of clean energy defines the future, France emerges as the protagonist of a silent revolution. Deep beneath the soil of the Moselle region, scientists have discovered a hidden treasure: natural white hydrogen, reserves that could redefine the rules of the energy game. Meanwhile, across the Atlantic, the United States is closely watching this technological race, where electric cars and fuel cells compete for space on roads and in the public imagination. The discovery happened almost by accident. CNRS geologists, investigating methane concentrations in abandoned Lorraine mines, encountered something extraordinary: pockets of pure hydrogen reaching 20% concentration at 1,250 meters deep. As they drilled deeper, approaching 3,000 meters, the purity reached an impressive 90%. The numbers are breathtaking: 46 million tons of natural hydrogen, valued at $92 billion, equivalent to more than half of current global annual production. This white hydrogen differs radically from its industrialized versions. While green hydrogen depends on expensive electrolysis and gray hydrogen emits CO2, white hydrogen emerges naturally through geological processes, requiring no chemical transformation or energy expenditure. For the automotive industry, desperately seeking alternatives to fossil fuels, this could be a game changer. But how does this discovery connect to the cars we see on the streets? The answer lies in a technological battle defining our era. On one side, battery electric vehicles, which have dominated the last decade with impressive advances. Global sales jumped 25% in 2024, reaching 17.1 million units. On the other, hydrogen vehicles, until now limited by prohibitive costs and scarce infrastructure. France, however, is charting an alternative path. Instead of competing directly with electric vehicles in the passenger market, it's focusing its chips on commercial transport. The strategy is clear. While electric pickups and sedans win over consumers, hydrogen trucks and vans could dominate cargo transport. Stellantis already produces light commercial vehicles with a range of 500 kilometers and recharging in 5 minutes, numbers that make many electric vehicles blush. In the laboratories of Toyota, BMW, and Volkswagen, another revolution is taking shape. Solid-state batteries promise energy densities capable of offering 1,200 kilometers of range by 2025-2027. Meanwhile, Tesla, always disruptive, surprises the market with rumors that it might be exploring hydrogen fuel cells. The logic is tempting. Imagine a Model S that, instead of hours at outlets, recharges in minutes, like a conventional car. But the challenges are enormous. In the US, hydrogen infrastructure is practically non-existent. There are more electric charging stations in California than hydrogen stations in the entire country. In France, a station for trucks costs more than $1 million, and commercial hydrogen vehicles still cost 3 times their diesel equivalents. Energy efficiency is another battlefield. An electric vehicle converts about 80% of battery energy into movement. A hydrogen vehicle loses part of this energy in electrochemical conversion, gas compression, and transport, efficiency dropping to 30 to 40%. For every dollar invested in energy, electric vehicles have an advantage. But hydrogen counterattacks with powerful arguments. While lithium-ion batteries weigh hundreds of kilograms, reducing cargo capacity in trucks, hydrogen allows for maintaining payload. Additionally, its decentralized production could create local energy networks, especially in regions with abundant geothermal or solar sources. The French scenario illustrates this duality. In Paris, 2,500 hydrogen taxis circulate during the Olympics, fueled by 8 refueling stations. Simultaneously, the country invests $9 billion in electrolyzers for green hydrogen production, targeting 6.5 GW of capacity by 2030. It's a bet on all fronts, recognizing that different technologies will serve different needs. For long-distance trucks and aviation, where battery weight is prohibitive, hydrogen seems unbeatable. For urban and short-range vehicles, electric ones maintain the lead. In the US, this debate takes on specific contours. While California leads in both technologies with subsidies for hydrogen cars like the Toyota Mirai, most of the country still sees electric vehicles as the only viable option. Tesla, with its supercharger network and falling prices, dominates the narrative. But the French discovery brings new variables to the equation. If similar reserves are found in American subsoil, the game could change. States with traditions, in oil and gas like Texas and North Dakota, are already rubbing their hands at the possibility. Technical challenges persist. Extracting hydrogen from 3,000 meters deep requires advanced drilling technology, not to mention the risks of leaks. Hydrogen is the lightest element in the universe and escapes easily. France estimates that $700 million will be needed just to make the initial infrastructure viable. Meanwhile, electric vehicles continue their relentless march. By 2025, 25% of global new car sales will be electrified, with solid-state batteries promising recharges in 15 minutes. The emotional factor cannot be underestimated. For many Americans, the rumble of a V8 engine is part of cultural identity. Electric vehicles have gained ground with instant acceleration and cutting-edge technology, but hydrogen offers something different: the familiarity of quick refueling, the possibility of maintaining traditional automotive rituals. It's a dichotomy that divides even experts. While some see electric vehicles as an inevitable destination, others bet on the coexistence of technologies. In heavy industry, hydrogen seems unavoidable. 40-ton trucks would need 10-ton batteries. For decent range, economically unfeasible. Compressed hydrogen tanks weigh 90% less. Daimler and Volvo are already testing hydrogen trucks that could revolutionize American interstate transport. In aviation, projects like Airbus Zero promise aircraft powered by liquid hydrogen by 2035. The geopolitical factor adds layers to this scenario. France, by developing natural hydrogen, could reduce its energy dependency and even become an exporter. For the U.S., the question is strategic. Invest in the local battery industry, or prepare for a possible hydrogen transition? The answer seems to be diversification. GM and Ford accelerate investments in electric vehicles, but maintain parallel hydrogen programs, especially for commercial applications. Consumers are caught in the middle of this technological whirlwind. On one side, increasingly accessible electric vehicles. Average prices have fallen 18% since 2022, with charging networks that already exceed 150,000 points in the U.S. On the other, the promise of clean, fast hydrogen, still restricted to few models and regions. The math is cruel. Fueling a Mirai costs the equivalent of $16 per 100 miles, versus $12 for an electric vehicle, depending on local rates. But the game is far from over. The French discovery may be just the first of many. Estimates suggest that global natural hydrogen reserves could exceed current natural gas sources by 100 times. If extraction technology evolves, costs would plummet, making hydrogen competitive even against fossil fuels. For car enthusiasts, this means more options. Electric sports cars with brutal acceleration for enthusiasts, hydrogen SUVs for families who travel a lot, silent and emission-free trucks for highways. Meanwhile, in American dealerships, the battle takes place in the spec sheets. A Ford F-150 Lightning offers 480 kilometers of range for $55,000. A Hyundai Nexo hydrogen vehicle reaches 612 kilometers, but costs $60,000 in few states. For many, the choice still falls on existing infrastructure. It's easier to find an outlet than hydrogen. But as France shows, public policies can quickly change this landscape. The future will likely not be one of replacement, but coexistence. Cities powered by lithium batteries for short distances, interstate highways crossed by hydrogen trucks, airports fueling planes with clean fuel. The French discovery accelerates this transition, showing that innovation can come from both laboratories and the bowels of the earth. For Americans, passionate about automotive freedom and innovation, this technological duality may be precisely the path to a future where performance and sustainability are not enemies, but allies on the road to decarbonization.